Okay, so we're going to look at expected value. Let's say you've gone to a fair or some bingo, some raffle, and they're selling tickets, and there's a grand prize. So there's only one grand prize where you can win $1,000. There's 5 second place prizes where you can win $100, and there's 20 third place prizes where you win $10. Okay, the tickets are all being sold for $2 each, and they have a total of 1,000 tickets. Okay, so the first thing we want to figure out is the probability of winning each of these events. What would be the probability of getting first prize? How many first prizes are there? 1. So there's 1 out of how many tickets are there?
1,000.
1,000. So you have a 1 in 1,000 chance of winning first prize. What's the probability of second?
5
Yep.
in 1,000.
5 in 1,000. Yeah. And third?
20 in 1,000.
20 in 1,000. Okay. So we have 3 of them right there. And there's technically a 4th one. What would be considered 4th prize?
Nothing.
Nothing. You win anything. And what is your probability of winning 4th prize? How would we figure that out? What would we do with these values?
1,000.
Well, it's not 1,000 of 1,000.
Minus the rest of them.
Yeah, so because there is a 1 first prize, 5 second prize, and 20 third prizes, we put those all together, you have 26 chances of winning. Right? So if we have 26 chances of winning, that means we subtract that from 1,000, right? And that'll give us 974. 900 of not winning. In other words, the probability of getting $0 is what?
974 over 1,000.
Over 1,000. So we kind of want to see if it's worth it to buy a ticket. What's the expected outcome? How much money are you expected to win? Right? And this is a lot of times how pricing of tickets are made. So what are our expected outcomes? So we have our values, and sometimes they set it up with like an X value and a P at X, P at X being our probability. So let's try to set it up ourselves. Okay? For our first X of 0, of winning no money, we have a 974 out of 1,000 chance. That's the probability of getting no money. Probability of getting $10 was a 20 in 1,000 chance, and we can reduce that, but it's not technically necessary. Of winning $100, whoops, whoa. Of winning $100, we had a 5 in 1,000 chance, correct? And of winning $1,000, we had a 1 in 1,000 chance. So what we do is the formula used for expected outcome is the sum of X multiplied by your P at X. So essentially what we're doing is we're going to multiply these by each other, and then we're going to add all of them together to get an expected value. Okay, so our expected value in this case is equal to, we'll kind of color them. So first one to do in red is 0 times 974 over 1,000. What is that number going to end up being when I multiply those two? You don't need a calculator. Think for a second.
0.
0, yeah. Anytime you multiply 0 by anything, we're going to get a value of 0. So that's going to be 0. It's not going to give us any good in terms of our expected money earnings. The second one, and we have to add it together because it's a sum of. I hope I have room here. You know what? Maybe I'll just go underneath. That way we won't run into this issue. The second one, we'll do in green here. Probability. Well, the X value, right? Remember it was X times P at X. Okay. Sorry, it's usually written like that. Probability of X. The second one was you're going to win $10. Then you have the probability of 20 in 1,000. So we'll have to multiply that. The one after that is our second prize, and your second prize you can win $100, and you have a 5 in 1,000 chance. And finally, our final grand prize, you can win $1,000, and you have a 1 in 1,000 chance. Okay? So in other words, this is going to calculate how much money we're expected to earn from buying a ticket. Okay, so the first value is 0. The second value here, we'll take a calculator out. This is going to be 200 over 1,000, which is a fifth, I think. 0.2, that makes sense. No, not 200, it's 20. 0.02. You guys want to correct me on that or no? 0.02. Good. I am okay at math. 0.02. Good. Oh, sorry. Times 10, which is 0.2. I was right. Sorry, I did the math in my head. So times 10 gives us 0.2. Our next value is 500. So I multiply the 100 times 5. It's like multiplying fractions. So we have 500 over 1,000, which is a 0.5. So we have a 0.5. That's what that value is. And this is 1,000 times 1, which is the value of 1. You can just push it as well. Of 1. Okay. So we add all these together, and the expected outcome ends up being 1.7. And because it's value of money, that's how much money we're expected to earn. So in other words, when we buy $2 tickets, thank you. When we buy a $2 ticket in this lottery, we're expected to win $1.7 or $1.70, which means, is it really a good idea to buy into this lottery? When I pay $2, my expected outcome is 1.7, so I'm already expecting to lose 30 cents. And most lotteries are set up that way. They wouldn't have an expected outcome where if you're buying a ticket for $2, your expected outcome is larger than $2. Otherwise, you would try to buy all the tickets. Okay? Right.